Hi everybody, this is just a quick video for anybody who's been working with the ribF protein. So I did this rather quickly. I was working with Caitlin, so if you talk to Caitlin, you can thank her for pushing us to work our way through this and talking about the weirdness that happened with her particular sequence and cloning. So what I did is I built the PET32AHA ribF plasmid. So you can see this the ribF coding sequence here in frame with the TRX tag, etc., etc. And what we're going to do is we're going to compare this against the T7 and T7 terminator sequencing. If you've been doing this, you may have noticed something a bit weird. And so let's just start with the T7. So here's the alignment that's already done. And I'm going to turn off this split workspace so we can see this whole thing. So I'm going to scroll out here. So this is where our primer binds. This is the T7 promoter region. So the primer would sit here. And we start getting sequence in this orientation. And as per usual, we don't get sequence right off the bat. It starts to kind of work its way out eventually. And we get great sequence. And it's fantastic, nice tight peaks. We goes to the TRX tag. Scroll, scroll, scroll. Goes through that first his tag here, which is great. Thrombin site S tag. Goes into the sequence of ribF. So far, so good. And so here's our ATG, etc. And there's the sequence of ribF. There's a few small discrepancies here where there's a duplication here. It looks like there's a mixed trace, and that this one has a possible mixed population here, and that some of our colonies, some of the plasmids that we gave naps have an A, and some of them have a G, and we've got this mix here. So that's our first indication that something might be weird. Maybe we don't have a pure colony. Maybe we didn't pick a single colony. Here's another indication that maybe it wasn't a single colony. We've got C's and also a T that kind of pops up underneath. But otherwise, everything seems to be going okay. And this wouldn't necessarily change much. It might change a single amino acid, but it's not going to cause a stop codon. There's some other small discrepancies here that start to think, well, maybe something's a little weird again. Here's a duplication. But it gets really weird right here. And Benchling does its best to try and match things up, but right after this point, the sequence goes super weird, and it starts to put these gaps in an effort to align the sequence, and you can see it doesn't really get better as we go along. So the question is, what the heck is happening here, and what happens at this point? Well, this bit I've highlighted here, we're going to read it out, AAGCTT. I'm going to let you think about it. What is AAGCTT, and where have we seen that before? Now I'm going to show the, oh no, it's gone. Dang it. Give me 1 second, I'm going to get something back here. I'm going to pause this for a second. Oh, I found it, it's right here. Okay, AAGCTT, remember that. Here's a lineup of our plasmid sequence again, but with the T7 terminator sequence. Now, the T7 terminator is out in this orientation, so you'd start to get some sequence in this way, but I mean, right off the bat, the sequence is garbage. It doesn't line up properly. Where is our his tag? Where are the HA tags? What the heck is going on? But suddenly there's definitely some ribF here. Something weird is happening because this terminator sequence has lined up here. What is happening? And actually it looks pretty good, but look at underneath. Look at the background noise here. There's something really odd happening. So why are we getting this oddness? Look here, you can see there's duplicates of a lot of peaks. It looks like we're still getting good reads. We're still getting something that matches up with the expected sequence of ribF. But let's scroll right out here to where things go really screwy again. AAGCTT. Now look how clean the AAGCTT is, and look at the background that is behind all of this sequence, and suddenly the background is gone. These 6 spaces don't have any background. AAGCTT is a HIND3 site. What this is indicating is, in the middle of the ribF coding sequence is a HIND3 site. There's not supposed to be a HIND3 site in the middle of ribF. If we look at just the ribF map, it isn't indicated. So what might have happened is either the BL21 strain that we use as a template happens to have a HIND3 site in the middle of it, or during the polymerase chain reaction, there was a mutation and it introduced a HIND3 site here, which was extremely unlucky. And so when we did the cloning we might have ended up with was just a monster plasmid that doesn't contain the entirety of ribF, and so we've got something weird happening. And what we did is we accidentally picked a mixed colony to isolate plasmid from and send off to NAPS for sequencing. That would result in this weird duplication of signal. So there probably wasn't an equal amount of plasmid, equal of the truncated ribF and the entire ribF, but we sent that off to NAPS and we get this weird sequence. So there's clearly something there where ribF was cloned properly, but underneath it is something where ribF was probably shortened, and that's that little trace we see underneath. And it all comes back to the weirdness that is this presence of this HIN3 site that's present in both the T7 sequencing and the T7 terminator sequencing. So this would probably mess up things like our Fairbanks and our Western blot later on. If that's not clear, then for sure let me know. I'm going to put this up on Canvas, and I'll let everybody know on Piazza to have a look at it.